Welcome to the CFE Media and Technology Education session. Engineering educators, are you leveraging the power of digital transformation in the classroom? I'm your moderator, Mark T. Hosky, with CFE Media and Technology. CFE Media has met the standards of the Registered Continuing Education Program. In keeping with our CEP policy, please take some time to read the quality assurance slide. This session is designed for technicians and engineers, trainers and educators who want to understand how to increase the skill sets of personnel after identifying challenges and upgrading technologies to help streamline businesses for the future. This session will demonstrate how advanced manufacturing training can improve understanding of required competencies, Industry 4.0, Industry 4.0 technologies, and the use of industrial data. Here's a list of learning objectives. We'll touch on these in today's presentation. Additional resources can be viewed and downloaded on the left side of the screen below the session's agenda. For a seamless online experience, here are some tips. Additional resources can be viewed and downloaded on the left side of the screen below the session agenda. If you'd like to take notes in the session, click on the left panel labeled Notes to do so. Please remember that this session will be made live at 2 p.m. Central, 3 p.m. Eastern. Question and answer session with industry expert will start approximately at 2:45 Central and 3:45 Eastern, or immediately after the presentation ends if it runs a little longer than 45 minutes. Answers will be archived with the session. You can see the Q&A details in the Meetings tab on the left side of the screen. Zoom invite details can be found in the Additional Resources tab under the Q&A session. Want to take the session again? No problem. The session will be available on demand. If you're experiencing difficulties, please log out and back into the session to continue. Finally, achieve continuing education credit by passing the final exam at the end of the session. Here is some information about obtaining an approved PDH for today's session. And now, please see this message from our sponsor.
The enormous rise in the quantity of data and the complexity of networking a plant requires developing systems that make the flow of data easy to handle. MES is what we call a manufacturing execution system, and it is the heart of Industry 4.0. This is the layer of controller software that truly connects the top floor, which is your ERP, your Enterprise Resource Planning System, into your actual production shop floor process. The true value of an MES is that you have full interoperability, meaning the shop floor communicates to the top floor. Decisions are made, and that goes back down to the shop floor for the implementation instantaneously. This takes all of your data, smart sensors, your condition monitoring, as well as your customer production orders, and combines that into a system where we can have dashboards and we can see what our cycle times are, what our idle times are, and how much energy we are actually consuming.
It's very important that skilled workers understand intelligent components in order to operate and optimize their facilities. It's also very important that they learn not only the structure, but they also know how to program the digital facility networks.
With the CP Lab, we've implemented MES4, which has all of the same functionality of an industrial MES, but it's built for the classroom, meaning it's easy to implement as an easy user interface, but it still gives you that full interoperability. It still gives you the capability to export data and make decisions, to do data analytics.
With this interface between research, production, and training, Festo Didactic works on providing learning systems and curriculum which students and skilled workers can actually prepare themselves for digital production, and the CP Lab can get you there.
Today's speaker is Ted Rozier, Director of Engineering of Festo Didactic. I'm your moderator, Mark T. Hosky, Content Manager, CFE Media and Technology. Ted Rozier is Director of Engineering for Festo Didactic Solutions Center, North America, with headquarters in Mason, Ohio. Before joining Festo Didactic, Rozier brings 20 years of experience in leading the automation engineering department for Doosan Infracore Machine Tool Corporation. He specialized in the design and development of robotics and machine tool turnkey systems for automotive, aerospace, and pharmaceutical industries. He has managed the development of several user-friendly automation-controlled turnkey systems on a global scale. As Director of Engineering of Festo Didactic, Rozier is passionately looking to advance Festo Didactic as a global leader in designing and implementing Industry 4.0 learning factories and demystifying Industry 4.0 career pathways with the view to systematically prepare individuals to excel working in dynamic and complex industrial automation environments. Ted, please go ahead.
First of all, I'd like to welcome you all to the webinar entitled, Are You Leveraging the Digital Transformation in Your Classroom? On behalf of Festo, I would like to just state that we're very thankful for the opportunity that CFE Media and Technology has given us to discuss a topic that impacts industry as well as education. Now, whether we call it Industry 4.0, the fourth industrial revolution, or I 4.0, I believe that one thing is very clear right now. It's that we are a bit fatigued in hearing the terminology. Everyone is kind of striving to understand what is Industry 4.0. How does it lead to this whole digital transformation? I was just talking to a fellow colleague about this topic of Industry 4.0, and something came about in our discussion. We kind of said that if Industry 4.0 were a box, everyone is striving to grab that box. But we've grabbed the box now. We have it in our hand. So now everyone wants to know, I'm glad that I have, but what's inside of it? Can you please tell me what's inside of this Industry 4.0 box so that I can be a part of it? And so today, that's going to be one of my goals. It would be to make the digital transformation, how does it relate to Industry 4.0 and to make it tangible? The other thing that comes to mind when it comes to Industry 4.0, before we jump into this topic, it's just that I go back maybe 7 years ago when I got into the education space, and we were screaming at that time, Industry 4.0 with a bullhorn. And a lot of educators just were ignoring it. But one thing I can say is that we are seeing educators now, 2021, especially as we transition through a pandemic, we are seeing educators that are now looking to utilize the Internet of Things more and more. So this whole digital transformation actually has taken us to a point in technology where we had to use it. And so now we're starting to see individuals just thrive along with IIoT methods. So let's go ahead and start to talk about Industry 4.0 and the impact, or what is it that it actually brings. When we think about Industry 4.0, it brings with it an increase in dominance and reliance on technology to produce far-reaching efficiencies across a wide variety of sectors. The revolution of Industry 4.0 was giving manufacturers faster, more flexible, and more efficient processes to produce higher quality goods and lower costs. So while we're all excited about the new technology and advancements, it is very important that we understand that Industry 4.0, it is not just about the data and data management. And we're going to talk about that throughout our discussion today. But it also defines or involves people, how we think, and also how we react to problems, which also lends itself to one of the biggest changes, and that is employability of the workforce. This first slide that we're going to look at here really will help us to understand Industry 4.0. So let's just kind of start at the foundation, and then we'll work our way up, just so we're all on the same page mentally here. So the first industrial revolution, we would call it Industry 1.0. And that first industrial revolution moved society from manual to mechanical by harnessing steam and water power, replacing raw muscle and strenuous craftsmanship. This marked the end of the 18th century. Now, again, the overarching terminology for this phase would be called Industry 1.0 mechanization. Now, we transitioned to the second industrial revolution, which took advantage of electricity and the assembly line to generate mass production. This marked the start of the 20th century. And again, that overarching term would be the overarching terminology here for this phase would be Industry 2.0, electrification. It takes us to Industry 3.0, the third industrial revolution. It took off using electronics and software. The most iconic example of these two coming together being the computer and the PLC, programmable logic controller. Now, in the industrial atmosphere, this gave rise to an era of high-level automation, and it marked the start of the 1970s. Again, that overarching terminology for this phase would be called Industry 3.0, automation. That leads us to our discussion today. What are we talking about? Industry 4.0, the fourth revolution, is a revolution that's happening right now. Now, according to research, the physical world, the digital world, and the virtual world are all colliding together, creating smart products, procedures, and processes which make smart factories. The study goes on to describe this revolution being brought on primarily by cyber physical systems and the Internet of Things, which create highly intelligent, integrated and automated manufacturing ecosystems that span far beyond the traditional factory floor. The overarching terminology would be called the fourth industrial revolution, Industry 4.0, or like we said in the beginning, I 4.0, or whatever you want to call that. That's where we are. And that's where we are on the bleeding edge of. And we will talk about exactly where we stand presently. Now, when we talk about Industry 4.0, it is important that we have an understanding of all the buzzwords that come with Industry 4.0. Here, this slide defines a lot of the things that come up around the topic of 4.0. Big data and analytics, the Internet of Things, cybersecurity, simulation, augmented reality, a digital twin, collaborative robotics, the collection of data versus I've had the data, now what do I do with it is a question. And then artificial intelligence, machine learning, OPCUA, unified architecture, the overall system approach. Okay, so there's a lot of buzzwords that come with Industry 4.0, and it also makes it a little blurry as far as where do I get started? Because with everything we do, we need a blueprint. You need a roadmap. You need to start at the foundation and build yourself up. So where do we get started? So when we think about that, I like to start here. Cyber physical systems. So let's clear our minds and think about cyber physical systems. When we think about cyber physical systems, we'll read it. Word for word here, the definition. What is it? The integration of physical processes, computation, and networking, collecting and harnessing a tremendous amount of data to make better decisions. In the end, collectively, the data should do what? Tell business leaders and all other disciplines working with that data from the top floor to the bottom what to do and when to do it. The data should tell you what to do and when to do it. So that is how we would define cyber physical systems. So again, let's clear our minds just like we did and like the image, using your mind's eye now. Let's go into Industry 4.0 and find out a little bit more about how to have a clear understanding of this digital transformation. The first thing that we need to do when it comes to cyber physical systems and building ourselves up would be understanding the control architecture. So we want to unleash the power of our control architecture. And notice here on the left-hand side, we have the classic pyramid. That classic pyramid is what we always talk about when you hear someone say the shop floor to the top floor to the shop floor. They're talking about the classic pyramid. To the left. As engineers, we also call that classic pyramid the automation stack. But at the top, you have ERP. At the bottom, you have the shop floor process. You have the PLC, you have the HMI. But what was missing many years ago is what's highlighted in blue there, manufacturing execution system. Now, we're going to talk a lot about that today when it comes to digital transformation or Industry 4.0, because that is what we would really call the heart of it all. Years ago, at the top, you had ERP, and that's where all of your work orders would be defined. But in between ERP and SCADA were a bunch of meetings, a bunch of paper and meetings. So you can see the power of MES. The power of MES means that now you have a place where work orders can be sent to an MES platform, and that MES would then distribute data down to the SCADA system, to the PLC. Now at the bottom, you have something additional there that's part of 4.0, and that would be operating on the edge. And we'll talk just a bit about that on the right-hand side. The main thing I want you to see is that we are talking about unleashing the power of your control architecture. So is it flexible and adaptable? But what's the difference in the classic pyramid and where we are today? Well, notice that cloud-based analytics, we have to deal with that. Operating on the cloud. And then you also have the edge devices. Edge devices are devices that would not reside, or the data would not flow through the PLC, but it would be on possibly on a computer, and that computer would then be connected and it would be pulling data from the cloud, but not going through the PLC. So understand that where we are when we talk about Industry 4.0, we need to make sure that we can see that an MES, manufacturing execution system, should be implemented. That's where your connectivity is. That's going to be the connector between the top floor to the shop floor. And then you also need to be able to query data from the cloud as well as from the edge and the PLCs. So we're looking for an overall flexibility and adaptability. Now, when we talk about Industry 4.0, and we've spent some time on the control architecture, there's something that we should always keep in mind. And this slide is going to really help you to understand where we are presently. We talked a little bit about having a roadmap. And Industry 4.0 really, when it comes to that roadmap, you need to be able to look at it and understand, where do I start and where am I going? So can I see around a few corners? The first thing you want to do is look at phase one. So phase one, phase two, phase three. When we look at phase one, we start off with lean manufacturing. So why is it that we would start off with lean manufacturing? Well, there is a saying, garbage in, garbage out. So when it comes to collecting data, let's just think about a shop floor in an environment. And we're really speaking to manufacturers right now. A shop with inconsistent or illogical processes and procedures effectively produce garbage data. At least that's from a high level or analytics perspective. If you start off with lean manufacturing, you just have a simple rule of thumb. So if we always talk about data, uh, you could just chase your tail. But if you start off with just a good dose of common sense, that would be where lean manufacturing comes in. Again, so think of 5S first, connect 5S to a healthy dose of common sense. Number two, the other thing is, let's just talk about if you're a fabricator. A laser cutting machine operator continually walks across the entire plant floor to just get a tool. Is that good? Well, if he just threw a little bit of common sense at it and had all of his tools at the machine with him, he wouldn't need to waste that time. So you can see the beauty of making sure that you just have process in place. Lean manufacturing. You don't need anything sophisticated. You just need to throw a dose of common sense. Let's go ahead and move on to discussing how we can move on into phase two. Now, step two involves connectivity. When we think about connectivity, a lot of customers buy products or parts. And when we think about machine uptime, the uptime of a machine is what's most important. And that's going to be when we look at the connectivity, and we can kind of look at this from a CNC machining standpoint. We think of a CNC machine operator or a programmer. The first thing that he does is, from a connectivity standpoint, many years ago, the part program was on a piece of paper, and they would kind of write down the coding, and they would go in by hand and enter all the code. Of course, now when we talk about connectivity, we're talking about having the ability to connect to that machine, and we're using an Ethernet cable. We're not talking about ones and zeros. We're talking about bytes of data, being able to push and pull that data. So that means that all of my machinery needs to be connected. We need to have interconnectivity. That means that from a gauging standpoint, am I able to look at my throughput and find out maybe through a CSV file? I can see all of my timestamps. When did my machine turn on? When did it turn off? It doesn't have to be a CNC machine. It can be any type of a manufacturing equipment, but do I have the heartbeat of it? So that's what we talk about when we say connectivity and computerization. It's not just connecting a cable, a wire, and we're posting 5 volts or 24 volts, and we're turning some kind of a relay on, and we get a 1 or a 0. But again, we're talking about bytes of data, being able to push and pull. That's when we know that we've taken care of phase one. Now we move on to visibility, transparency in phase two. And then also phase three would be predictive capacity and adaptability. When we think about adaptability, that means that we have an autonomous response. An autonomous response is achieved. That's without human intervention. So that's the goal, that we throw a dose of common sense, that we have connectivity, able to push and pull data, and then we get into visibility. Can I see what's happening? So let's talk a little bit more about seeing what's happening and understanding why it's happening. We'll look at this slide here, and visibility is the first topic in phase two. And then there is transparency. So that's where we're trying to get. If we've done things the right way, then we're able to look at our PLC. And what is it that we want from the PLC? For many years, PLCs have been used in the manufacturing market, and basically any repetitive task, PLCs drive, turning a conveyor on, turn the conveyor off, turn an air cylinder on, turn the air cylinder off, any repetitive task that's given to a PLC. But I need more. When I talk about Industry 4.0, I need more from the PLC. So at the bottom of this slide, notice it says PLC data. What do I need from the PLC? Well, I need the in-feed data. I need the out-feed data. I need waste. I need the state of the equipment. So really quickly, what's the storyline look like from the PLC? Because I've got expectations for that guy. How many parts am I putting in the system? And how many parts do I expect to get out of it? And out of all those parts that I'm putting into my system, all of the widgets that I am creating, how many widgets am I wasting? So do I have quality check? And are all of them good widgets, or are there some bad? And then the state of the equipment is the heartbeat. That's the heartbeat. Every PLC, if it's designed the right way, the programmer, it goes and uses good practice, he's going to make sure that the pulse of that PLC, the scan time, that would be 5 milliseconds, 5 to 3 milliseconds, but that's the pulse. And I want to know, is the PLC actually scanning? Is the machine up and running, or is it down? So that's what I need from my PLC. If we move over to the next box at the bottom, we have the MES data. So that MES data, that's the heart. And what is it looking for from the PLC in the overall process? Availability, quality, and performance. If I have availability, quality, and performance, now I can start to paint a picture. The picture leads me to that third box on the right, visualization of data. And what are the tools that I need for visualization? I need an MES platform to see that visualization. I need an HMI to help me to troubleshoot the system. And I need mobile device. Do I have connectivity can I use my mobile device, my cell phone or a tablet, to connect to the system and find out the heartbeat? Am I making enough widgets today or not? And who needs to know that? It needs to be the top floor to the shop floor. Everybody needs to be able to, whether I'm a CEO and I get off of an airplane, I want to know, how many widgets am I making today? And if I'm the plant manager, I want to know, am I making enough parts today? If I am the maintenance technician, I want to know, I've got a machine down. Everybody has the same dashboard and able to at least learn. Again, as we get a little bit further down or through our discussion, we're going to talk about a little bit more about the expectations of job roles and how to unleash the power of visibility and transparency. But the last thing that I want to say about this slide here is there's a term at the top, two terms. One is data conduit, but underneath that is the term of interoperability. For many years, we have been pushing data one direction. But you see that arrow goes two ways. When it comes to interoperability, I need to push and pull. And when I push data, that means that if a motor is hot, there is a temperature switch on the motor. That's been that way for years. I can quickly look and see that motor is getting hot. That's great. But in the era that we're in now and where we're going, that motor getting hot should tell the operator something. The system should be able to say, before it gets hot, I'm running too rich. It should anticipate the error and make sure that the operator knows that, hey, there's something wrong here. So we're not looking at just pushing data one direction real time. We're looking at more of the anticipation. So we're talking about smart maintenance, predictive maintenance pulled together where we're able to predict. And I need to know where I should be looking. So I'm not just looking for a gauge of 1 to 10 or 1 to 100. I'm looking for a pictorial image. That's why we talk about visualization. Okay, so we look at that data conduit. Data collection is number one, transformation, exploration, modeling, analysis, visualization. These are the terms that we are looking for in order to transition out of step 2 and to get into step 3 of Industry 4.0, or that digital transformation journey. Why do I need to collect all of this data? Well, there's a term that you should always keep in mind, and you should be very intimate with, and that is overall equipment effectiveness. So what is that? That's something you want to keep on the forefront of your mind. The overall equipment effectiveness provides a complete overview of the productivity of a machine. So we talked about what it is that we're looking for, the expectations from a PLC in the last slide. I have expectation for a reason. It's because I need my overall equipment effectiveness. I need my OEE. This is what's going to tell me if I am doing the right things. So OEE will give me the utilization rate, the performance rate, and a quality rate. And that rating should assist me in my overall plant throughput. It should tell me, is it healthy, or if I need to make some changes. But I need that equation, and I need to understand from the PLC and the MES, looking out at the whole process. I need that equation to come together, and now the data starts to make sense for me. So thinking about OEE, why is it important? Just a few key things. This slide helps us to see that when it comes to availability, unplanned stops, that's one of the recommended 6 big losses in a manufacturing plant. Not having OEE, the availability loss, that means that my overall process, I'm not going to be able to track it. So I need to understand availability. I need to understand, when does my equipment shut down? And then I can then, now I have an understanding of what to do as far as an adjustment. The performance loss, quality loss. So OEE is very, very important. Now, we talked about the Industry 4.0 maturity index a bit, and at the bottom, you'll see lean manufacturing, a dose of common sense, computerization and connectivity, number 2. Notice it says now. That's where we are. If we gauge globally, phase 1 and 2, we are starting to see, even in the education space, they're starting to have a clear understanding that these competencies or disciplines should be taught. Lean manufacturing, computerization, and connectivity. What's next? Visibility and transparency, and then 5 and 6, predictability, and of course, adaptability. But we know that Industry 4.0 is not just about the data. Early on, we talked about this, that it's also about the behavior of individuals, people, how they think. So how we think goes right along with this overall index. What we're going to do now is watch a video and actually see what does Industry 4.0 or the digital transformation on the manufacturing floor look like if we drill down into just data management and how to push and pull data with RFID.
So what did we learn? Our Industry 4.0 training solutions come well equipped with all the tools needed for success today and tomorrow. But let's start off with the RFID chip that is embedded inside of each carrier, which allows us to push, pull, and store 128 bytes of data on the chip. Now, at each station, we have what we call a stop gate. The stop gate consists of 4 digital proximity sensors. These recognition sensors allow us to collect binary data in clusters for part type management, as well as an RFID sensor. We also have an air-driven stop gate cylinder, which is basically an actuator that stops the part when it comes in, or the carrier when it comes in, and then allows for us to push and pull that data like we talked about earlier. This means that at every station that the carrier stops at, we have the opportunity to query the MES and ask the part, what's happening? Remember, that has to do with visibility. And then after what's happening, then we have the ability to say, why did it happen? And that's transparency. Let's now see the system in reality. The part will enter the magazine station and put one part on top. We now enter into the pressing station. Once the part is pressed, it moves over to the turnover station. Now keep in mind, at each station we are pushing and pulling data. The final station would be the labeling station. I'm going to remove the part from the process. Typically what would happen is the part would be packed out. But let's get back to what we're talking about. Here we're talking about traceability. So at the labeling station, what happened? A QR code was placed on to the part type. The information on the QR code comes from where? Our MES platform. So you can see that when we talk about traceability, it takes us back to our maturity index. That second phase clearly defined visibility to transparency. And what sits in between both of those? Traceability. So the MES platform speaks to the RFID, and we push and pull there, and we also get a chance to speak to the label maker and define what on the part. We get a chance to review the QR code as well as the timestamps, the order number, and the order position. With all of this technology blended tightly together, Festo Didactic is sure that we have the most powerful tools for today and tomorrow.
So we've talked about where we stand when it comes to the maturity index. We've talked about data management in Industry 4.0 and how to push and pull data. And we've talked about some new ways of doing that, RFID technology, and of course, everything needs to be tightly blended together. The MES should be querying all the time, asking, who are you? Why are you to the manufacturing floor? And then the MES is also asking, connected to the cloud, and it's asking, do you have some more data for me to feed to the manufacturing floor? So you have a lot of whys when we talk about 4.0, and is the system adaptable in order to be able to make swift adjustment at the touch of a button? Can the system think on its own? It should be a think tank. But what does that do when it comes to job roles? Some individuals think that, well, the era that we're stepping into, Industry 4.0, has a lot to do with the collaborative robotics, robots, and if you are if you have a data-rich experience, that means that artificial intelligence and machine learning will be used, and it's going to put people out of work. And that's not the case. We're going to look at 4 job roles. Industry 4.0 production specialist, the Industry 4.0 smart maintenance specialist, you have the Industry 4.0 smart process specialist, and you have the Industry 4.0 system integration specialist. We'll spend a little bit of time on this. When it comes to job roles, the pressure right now would be at the top. The pressure is on the system integrator, because the system integrator, his job is to have the understanding of how to make machinery smarter. And it's not that it's so smart that the special sauce is when we talk about the special sauce, it's the connectivity. Um, and it's the special or secret sauce because how you connect software to the hardware. Um, the way you do that, it's done many different ways. There's a lot of different methods. But in the end, the system integrator needs to tie that system together so that the production specialist his job should be easier. The machine is smarter. So now the production specialist at the bottom is now using rich data. He's using visualization that's telling him a lot more. In the past, the production specialist, as soon as he saw a red light, he say what? Bring the maintenance guy over. The red light's on. Well, if the system integrator does his job right, that system should be speaking to the production specialist and anticipating when there's a red light. So now the production specialist has the ability to run several lines and use his brain for things that the machinery just can't do. So it's beyond any repetitive task being given to a robot. But now we're talking about sometimes when we look outside of automotive industry and we're talking about aeronautics where that gauging is important. It takes so long to make a part and to gauge that part that sometimes it's not good for it to be automated. That's what that production specialist should be doing now. Things that the machinery can't do. But it's up to the system integrator to make that machine smarter to give the production specialist the tools. Now we go up to the smart maintenance specialist. Again, he's not chasing red lights. He's walking around the manufacturing plant doing what? Anticipating. So he's doing predictive maintenance. And the one thing that I think is important with this whole Industry 4.0, I like to relate it to a term that we used to use when I was working on manufacturing equipment in the plant. We would always say, 8 and skate. I would love to get to a point where I can work 8 hours and go home. But from a controls engineering standpoint, it just never worked out that way. It was just always, there was a problem on a machine. And so you have to work 12, 14 hours. And it's really just about the efficiency of the manufacturing plant and how organized are things, how well is the equipment built. And that's why I think that this era of Industry 4.0, at Festo, we believe that this will allow the 8 and skate factor to actually come to fruition. But that last position there that we didn't talk too much about, you have the Industry 4.0 production specialist, you have the smart maintenance specialist, and you have the smart process specialist. The process specialist sits in between maintenance and the integrator. And he really understands the overall process in a plant. And he also understands very clearly throughput, the end-to-end factor. How many parts are coming in? And from a logistics standpoint, how many more robots do I need? Or how can I make this process where that it's user-friendly to allow more machinery to be run by maybe one operator? So he understands the process. So that's that role that sits right in between, and he's always thinking about how can I quickly get more parts out the building. When we think about these 4 job roles, the only way that you can in the classroom look to see, am I doing the right things, would be to look at the duty areas and to measure what are the things that the Industry 4.0 specialist should know versus the system integrator. So at the bottom, for all of these job roles, you have maintenance. And of course, there's 4 different types of maintenance: reactive, preventative, risk-oriented, predictive. There's analytics, where we talked about visualization, we talked about data and reports. There's troubleshooting, improvement, development, programming, and security. And of course, that hot topic of cybersecurity, permissions that we're seeing. So this is going to be how we gauge to see if we're doing the right things when it comes to these job roles. This is very important to go along with the maturity index. So we talked about where are we in the process? Phase 1, a dose of common sense. And then we talked about how that after a dose of common sense, we then have connectivity. But what goes along with that, of course, would be the job roles and making sure that we are measuring to see that we're teaching the right things and teaching those disciplines. How do I use connectivity? How do I use visibility to enhance my job? The last slide here would just be a roadmap. So here we have almost like 3 levels if you look at it. The fundamentals of Industry 4.0 in the classroom, and this is we like to call it. It starts off as a hook course, and that hook course is all about doesn't require equipment, but it just gets the students up to date on what are Industry 4.0 methods. But then, of course, it's a difference in 4.0 versus mechatronics. So there are going to be some things that we're going to have to push off the table. Some things you can't take for granted a bit because of the years of maturity that we have in PLCs. But as you start to get up to the top here, this is where you want to make sure. You want to make sure that, that your program is stackable and that you are leading the students to the point where they understand more around cybersecurity, smart maintenance, data management, traceability, interoperability. So always ask yourself, is my program building students up to the point where they are able to operate within that environment? And if you have the right things in place, that traceability piece, interoperability piece, then definitely those students are going to thrive. But teaching them about MES and how to use MES to read contextualized data, timestamps, and then be able to push and pull that information is going to be extremely important to your journey around Industry 4.0. So that's going to end our session. So we'll now turn it over.
Thanks so much, Ted, for showing us how to go on the digital transformation journey from lean manufacturing, computerization and connectivity, visibility, transparency, predictive capacity, and adaptability, and taking us through these 6 stages to show how it can be done. Here's Ted's contact information. If you need to contact him, please don't leave us now. It's time for the question and answer portion of the session. It immediately follows the presentation and is expected to begin approximately 2:45 p.m. Central, 3:45 p.m. Eastern, and go for about 15 minutes. This Q&A session will become part of the archived presentation. To participate live, see the live Q&A information with your Zoom invitation details. These details also can be found in the Additional Resources tab on the left side of your screen. Please submit your questions using the Zoom question and answer interface, and we'll start that momentarily. Thank you.